Konnichiwa. I wish I knew more Japanese. I'm sorry. At the end of March, the Amazon Prime Video team published a blog post. It was titled, Scaling Up the Prime Video Audio-Video Monitoring Service and Reducing Costs by 90%. The little subtitle read, the move from a distributed microservices architecture to a monolith application helped achieve higher scale, resilience, and reduce costs. As you can imagine, a blog post from an Amazon company with a subtitle like that caused somewhat of a stir. There was a lot of drama on Twitter with a lot of people that I follow and respect giving very different opinions as to what has happened. It was wild for a few days. And if you haven't actually followed what happened, I want to give you a quick overview of this very interesting story. So this blog post described a service that an Amazon team had written for monitoring the quality of every video stream viewed by customers, right? So this service allowed Amazon to identify quality issues like block corruption or sync problems, and then trigger a process to fix them. So the initial version of this tool had three major components. There was a component to convert audio-video streams to frames or decrypt audio buffers. There was a component to analyze frames or audio buffers for defects. And finally, there was a component for sending real-time notifications if an issue was found. And that initial architecture that was built was done using step functions and Lambda, and you can kind of see it on the slide, on the screen right now. Now, the author of the blog post wrote that using step functions and Lambda and S3 was, a good choice for building the service quickly and getting to production. However, they soon started hitting scaling limits at about 5% of the expected load. And furthermore, the cost at a large enough scale became prohibitive. So a couple of notes about this particular architecture that you can see. So the blog post states that the main bottleneck was orchestration management using step functions. Because they had to perform multiple state transitions for every second of every stream, they quickly reached account limits. Also, it was costly because AWS charges for per state transition. Next, the system was passing individual frames, basically static images, between different components. They built a service to split videos into these frames, into images. Then these images would go into an S3 bucket. Then defect detectors, which would run as basically little microservices, would grab frames from S3 and process them concurrently using Lambda. Now imagine the scale on that, right? Breaking down every video stream into frames, saving those frames into an S3 bucket, and having multiple microservices download those frames from S3 and process them in parallel. And I think people who are familiar with the kind of the serverless approach to software development quickly had a bad feeling about all this. So what did the team do? They basically re-implemented that serverless microservices architecture into what they called a monolithic application. In reality, really what they did is that they containerized and began using ECS. So they packaged nearly everything into a container and eliminated S3 as that intermediate storage for frames. So most of the data transfer was now done in memory. At a high level, the three main components in terms of the application logic remained the same. So this allowed the team to move quite quickly and kind of migrate to this container-based model, in a matter of months. Also, the team implemented an orchestration layer to distribute different requests to different ECS clusters, running different defect detectors. The takeaway that the team had at Amazon was that moving the system to a monolith, and again, they are calling it a monolith, and I think we can have a bit of a debate about that, but they said that this cut costs by 90% and increased scaling capabilities. Running containers on EC2 via ECS also allowed them to take advantage of EC2 compute savings plans. So they saved a little bit of money as well. So as you can imagine, this kind of a blog post from an Amazon company, from an Amazon team, moving a large chunk of the system from Lambda and step functions to containers resulted in quite the conversation. And so I had a number of thoughts reading through that blog post. This is apparently me reading and thinking using old computers for some reason. Like Eric, I always recommend, and like Alex, I always recommend going serverless first and then experimenting with other solutions if that doesn't work out. I mean, it is important to understand what the system, how the system will scale and what it is designed to do, right? You wouldn't go with a serverless approach if you need to do, I don't know, sustained ML inference training. But I think the best analysis came from Adrian Cockcroft. So he wrote this blog post. I have a little link at the bottom. Sorry if you cannot see it. He titled his blog post, "So Many Bad Takes. What is there to learn from the Prime Video microservices to monolith story?" And Adrian's take on this whole story was that the team's approach was actually correct. They wanted to get something up and running very quickly. They took the serverless approach and they succeeded. They got to market. They had the system running in production. Then, when they tried to scale and cope with higher traffic, they realized that some of the steps in the step functions workflow were too frequent and there were too many calls between Lambda and S3, so they packaged everything into horizontally scaled microservices on ECS. Now, one problem that Adrian notes is that the blog post kept saying that they went from a microservices architecture to a monolith, when it was clearly a microservices refactoring step. And I must add, this is why having clear definitions is very important. What is a monolith? What are microservices? Are we all talking about the same thing? A monolith, in my mind, is definitely something different to what that team was describing in the blog post. And Adrian also wrote that he's always recommended that if you need to process sustained traffic at a low latency, then your serverless prototype should be re-implemented as a continuously running auto-scaled container, which is part of your larger serverless event-driven architecture. And if you tried to build it like that from the very start, you probably would have had a tough time figuring out all the components and getting it to work. So according to Adrian, Amazon didn't get it wrong. They actually followed what he thinks is best practice. And this isn't some return to the monolithic architectures of yesteryear. But he does point out that microservices have been oversold as an answer to everything, particularly when it comes to Kubernetes. But that's another talk for another time. I will not mention the K word again. Anyway, it's a great post. Please have a read. It's very interesting. And there were two reasons why I was personally interested in that blog post. The first reason was this. A couple of years ago, I tried to do something similar. Not at the same scale, but also with video processing. It was an interesting proof of concept. It worked, and I wrote a few blog posts and gave a few talks. All I wanted to do was transcode or encode a video from one format to another and do it completely serverlessly. So take a video that's an MP4 1080p, make it 720p instead. And I wanted nothing but Lambda. So how would you do it? How would you break up a big video and do it all serverlessly? Here's the approach that I took. First, you have the original file. Then you can split it up into much smaller segments using Lambda. Then you can transcode each little segment in Lambda. Hopefully you can do this in parallel. Then you can start gluing things together and then get a new video in a different format or transcoding. Here is an architecture diagram using step functions in Lambda that I implemented. I'm not going to go through the architecture now, but if you're interested in something like this, you can have a read of the blog post that I have there that describes what I did. It's basically MapReduce, right? If you're familiar with that concept, but using Lambda. And it's amazing because Lambda is a supercomputer at our fingertips. We have so much power and we can do so many great things. One more slide. When I built the system, I actually benchmarked the serverless approach to running FFmpeg on an EC2 instance and my own MacBook. And you can see that for smaller files, the serverless approach was actually the fastest. And that is interesting. And it took me a second to figure out why. But it's because with serverless Lambda, we can do things in parallel. If you just run a conversion function like FFmpeg on your computer, it is done sequentially. The file is converted sequentially. Lambda is parallel. It's amazing. But here's the thing. If I was going to implement a high volume, high scale, constant throughput system, I wouldn't do it this way. It would be too expensive to run, just like the Amazon team found out, right? It's excellent for something small. It doesn't work as well for larger workloads. And I think this was evident a few years ago. So instead, I would maybe use off-the-shelf AWS Elemental's Media Convert, right? Great service for converting files. But maybe that's also too expensive. I don't know. So then maybe I would explore the option of running FFmpeg in a container, doing the encoding and saving into an S3 bucket. This is basically what Eric kind of mentioned in his talk. So the point is, this long-winded kind of diatribe, the point is we need to use the right tool for the right job, right? We speak about this all the time. Going with a pure serverless approach is right for some situations, but it is not a silver bullet. Maybe running code in a container is better, right? There shouldn't be a dogma to what we do. What is important is being able to think through the requirements, the architecture, and to articulate why you're making a certain design choice. Okay, enough of me ranting about serverless and architecture and video for a few minutes. I just want to say hello to all of you. And I'm so glad, so excited to be here today with you for ServerlessDays Tokyo. My name is Sbarski, and I'm genuinely touched to be entrusted to give a talk today. Thank you to the organizing committee for inviting me. Thank you to my sensei Shingo for the invitation. Thank you. And thank you for all of you for being here today on a Saturday. I want to draw on some of the experiences I've had over the past few years building serverless systems. And I want to talk about how I build applications, software with a serverless approach today. But first, let me just quickly tell you who I am. This is me. I'm an AWS serverless hero. I wrote a little book called Serverless Architectures on AWS. It has been translated to Japanese and Chinese as well, actually. So it's probably a little bit out of date now, though. So, you know, I helped to co-organize a serverless meetup in Melbourne, Australia. So if you ever come to Melbourne, Australia, please let me know. Would love to host you. I also helped to organize the ServerlessDays conference in Australia as well. For many years, I used to work for a company called A Cloud Guru, and I also organized a conference called ServerlessConf that Shingo knows very well as well. Recently, I have co-founded an AI incubator lab out of Melbourne. I co-founded this AI incubator lab with Sam Kroonenberg, who was the founder of A Cloud Guru. And I know that AI is in vogue these days. You know, people are jumping on the AI bandwagon. But here's what I want to say. AI is not the point for us. what we want to do is create incredible products that have a beautiful, wonderful, magical user experience. We want to get to a level of user experience that simply has not been possible before. And I think that with the power of cloud computing, as well as automation, and of course, machine learning, and generative and non-generative AI, yes, including LLMs, we can create something special. All of us can. And that's the aim of our incubator. Oh, yeah. So I left A Cloud Guru after it was acquired by Pluralsight. I had a little break, and that's when I started our incubator. We have a lot of ideas, but we are very lean. We don't have a lot of money, right? We have a small budget, but we want to try a whole bunch of different ideas and see what works. And right now we're working on our first product. I cannot say too much about it, but I'm hoping we can announce in the next few weeks. But before building the first product, we decided on a few rules. How are we going to build it? So first, we are going serverless, right? It will help us to iterate quickly, and I think it's the fastest way we can get to market. Although interestingly, we are running a whole bunch of containers because we have a number of ML workloads. And it's fine, we're using the right tool for the right job. Next, at our incubator, we only have 3 developers, and I'm one of those developers. So we don't have time to build everything, and we don't need to. So we have to use other services, AI models, third-party products to move quickly. We need to focus on what makes our product unique and not re-implement things like authentication or data storage or orchestration code. So my goal is to leverage as many AWS services and third-party services as I can. If a certain problem has been solved, I want to use the solutions and not build another authentication system. As I mentioned, we are small, and what I think will differentiate us, apart from solving the problem we are trying to solve, is presenting the user with that magical user experience. And I will talk more about that in a moment. And I want local development and debugging to be as easy as possible. Less friction in our development experience makes us go faster. So, as I said, we are serverless first. We use a number of services from AWS. We use Lambda, we use step functions, we use API gateway. We actually use a lot of WebSockets because they provide a really nice user experience kind of between the client and the backend. It's really nice. We, of course, use DynamoDB, as Alex would recommend. Although one thing, sorry to be controversial, I apologize to you in advance, we are not doing single table design. I'm sorry. We are not. And the reason for this is that single table design, at least for me, I'm not as smart. So it's difficult when we are in the exploration phase of our software. We don't know the access patterns yet. They are changing every day. So I try to be like Alex. I will succeed one day. I hope so. But for now, I have multiple tables. Event bridge for communications. So if we need to do a Lambda to Lambda call, we never couple Lambdas directly. We always use event bridge. And of course, S3, the service that everybody uses and will always use until the end of, of the sun. To help with the implementation, we use the serverless stack framework that Eric mentioned in his talk. So we use it instead of SAM or serverless framework or Terraform, and I'll tell you why. There's one killer feature that I love. So if you're not familiar with SST, it's basically, it's a framework. It helps you do local dev and debugging. It is built on top of CDK, and it has a nice little console for the administration of your resources. I just mentioned CDK. If you're not familiar with it, it stands for Cloud Development Kit, and it's basically a way to define your cloud infrastructure in code. you use it with a regular programming language like JavaScript or C# or Go, and you use regular programming constructs like conditions and loops. So SST builds on top of CDK. But here's my favorite feature, and this is why we use SST. So SST allows you to debug and test Lambda functions locally while they are being invoked by AWS. And the way it works is that it proxies requests from AWS straight to your local machine. So you don't need to mock any AWS services. You don't need to use local stack. You don't need to continuously redeploy your functions. SST deploys little fake Lambda functions into AWS and creates a WebSocket connection to your machine, to your computer. So whenever another AWS service invokes your Lambda in AWS, that request is seamlessly proxied to your computer. Your local copy of the function actually runs, and then the response is proxied back into AWS. And it is all seamless. You don't really know that it is happening. The way it works, there's a DynamoDB table, of course, that keeps track of connections. There's an S3 bucket that is used as a storage mechanism for request response messages. But for us as developers, we don't care. But the net effect is that you can put a breakpoint, 10 minutes left. You can put a breakpoint in your code. You can step through your code in Visual Studio as your code is running, right? So, I mean, yeah, we did this 30 years ago, but it's kind of amazing with a serverless approach. And it works very, very well. You can inspect your variables. You can do whatever you would as if you're developing locally, even though things are still running in AWS. So I mentioned that we want to develop products with a beautiful user experience, right? Something to elevate the user experience beyond what we are used to. So we are using large language models like ChatGPT to interact with our users or move them through the application in a more contextual way. And I think the ability of trying to contextualize the user experience or language or interaction is incredible. And it works well. So we use ChatGPT, we use GPT 3.5 Turbo, 4, Text DaVinci, we use image models like Stable Diffusion, we use voice models, and so on. Initially, when we started building our first product, I began using a framework called Microsoft Guidance. So this framework works with ChatGPT, and it allows you to control kind of the output from ChatGPT. And it's nice. You can say, hey, I want to get a particular structured response out of ChatGPT, and it will kind of try to get it for you. It works better with text-based LLMs. It doesn't work as well with chat-based LLMs because there's no capability for partial prompting, but that's okay. Well, turns out that Microsoft Guidance has been abandoned by Microsoft. I think all development has stopped. So we then switched to LangChain. And I know that there's a wonderful book coming out by Shingo about LangChain. So if you're interested in learning, please get a copy. I've ordered my copy. I can't read Japanese, but I've ordered a copy. So it's an open source framework for handling large language models, LangChain. And it supports Anthropic Claude, which is provided by AWS, and of course, ChatGPT. Look, I probably don't have time to go in depth into LangChain and how it works, but the nice thing about this framework is that you can write your prompt, then you can define the JSON structure that you want to get back, and LangChain will parse the output from the LLM and put it into the JSON structure that you defined. So when it works, you know always what JSON structure you will receive. It's very easy to then interrogate it and know what to do with it. I should mention that it doesn't work 100% of the time, because sometimes ChatGPT, the LLM, will not give you the right output. It may give you like truncated JSON, which cannot be parsed. So you then need to have some error handling in case that actually happens. I don't know if anybody is familiar with Amazon Bedrock. So this is a new service coming out. It's in preview, right, Eric, from Amazon. So it supports a number of foundational models, including Claude, which is like the alternative to ChatGPT, and also Stable Diffusion XL for image generation. I'm actually don't even know if I can share this image because it's technically not publicly available yet. So, whoops, I'm sorry. Yeah, it's. So the good news is that once you have access to it, getting started, it's incredible, right? It's very easy. It's like another AWS service. You create a request, you get back a response. Super simple. You don't need to think about scaling. You just use it as if you were using, I don't know, SQS or S3. I think Claude, the foundational model provided by Bedrock, it's not as good as ChatGPT as yet. At least for my use case, it's a little bit flaky. It's not very stable, but it's getting there. So as I said, Bedrock provides Stable Diffusion XL from Stability AI. And again, very easy to get started and to use it. But for some reason, it's like an older version of Stable Diffusion. It doesn't support all of the features that you can currently get with other providers. So yeah, I think it's cool. It's very promising. And maybe at reInvent, when it's released, we'll have all the latest, greatest features and bells and whistles. At the moment, we also run our machine learning models in containers. We use a service called RunPod. Sorry, AWS, and I keep looking at Eric, but in this case, RunPod beats ECS and Fargate and anything else, because RunPod can run containers on a GPU in a serverless way. Unfortunately, Fargate still doesn't support GPUs. It has been an open issue since 2019, I think issue 88. I looked it up recently. So of course you can do it yourself. You can provision a P-class instance and run Fargate on top of it, but it's just a little more hassle. But anyway, we still use step functions to orchestrate everything, and it's amazing what you can do. This is like last slide. I'm getting a sign that I only have like 4 minutes left, so I'm nearly at the end. I often think about a talk given by Tim Bray from a few years ago. Tim defined a few high-level rules for modern applications. And they include, these are the rules that he defined. Think about security and compliance first. Use microservices. Go serverless where possible. I feel like it's a theme. Have robust continuous integration and deployment pipelines. Make sure you have monitoring. And that's it. And you can go and watch his talk. It's still super relevant, even though it's from a few years ago. I agree with his take, and I just want to add a few more of my own. First, on the issue of microservices. I don't necessarily think that microservices are appropriate in all situations. I think the answer is that it depends. For applications at scale with multiple teams, multiple bounded contexts, a microservices approach is probably the right approach. But if you're working on a small project with a narrow bounded scope, if you're a startup wanting to get to market quickly, then maybe a serverless monolith is not such a bad idea. Maybe you don't need to go crazy up front with all the different microservices. I know I was very dogmatic about this when I was younger, but now I'm not so sure. Automation is a must. Serverless systems, as was mentioned before, are distributed systems. If you're using AWS, you're dealing with a whole bunch of other services apart from Lambda. you will have hundreds of interconnected parts. If you do not automate your upgrades, monitoring, deployments, the complexity of the system will get to be too much. Think through the testing strategy. I think that's a whole different talk in and of itself, which is very interesting. Go serverless. We mentioned this a few times. Go serverless first to enable experimentation and quick evolution. And then later, if you need to progress to containers or something else, that's fine too. And yeah, have a strategy in mind. Have a technical strategy. We have that serverless first strategy. We use third-party services and SaaS products. Just come up with something. Have like a guiding light to what you do. And I want to thank you for listening to me. I'm obligated to share my book with you one more time. I want to thank my co-authors, Jan and AJ. They are brilliant and know way more about serverless than me. There is another interesting book, The Value Flywheel Effect, and it's more for business people about how to kind of pitch serverless to your business, how to convince your business to go serverless. Interesting. And of course, there's a DynamoDB book by the one and only Alex Debris. So please get that book too. And with that, I really want to thank you for your attention. Thank you so much for having me. And it's been great. Thank you all.
はい、ありがとうございます。で、この後、ペーターが Ask the Speaker ブースにいてくれて、あと、通訳的な感じで、星をかぶったイジンさんって方が、助けてくれるので、ちょっと英語わからないとかあれば言ってください。はい、じゃあ、また10分休憩で、はい、ですね。11階に行く方は、同通レシーバーをあちらの方に、渡してからにしてください。